the solutions to assignment 1. So in question number 1, in the left column are memory segments and on the right column are registers that are associated with them. And we are asked to find which of them match to which. So the correct answer is option D, where the data segment gets mapped to the start index, source index, and the BX register, right? And the stack segment gets mapped to the base pointer and stack pointer. The code segment gets mapped to obviously the instruction pointer, and the extra segment gets mapped onto the for doing string instructions like moves or CMPSB. We have it with the destination index, right? So this is the mapping. In question number 2, we are asked to find out if the following assembly program has any errors. So if I had not used the prefixes for the pointers, byte and word prefixes, then there would have been an error. But given that I have used it, there are no errors, and so the answer is true. So what is the value of the zero flag at the end of this program's execution? Pause the video at this point and go over what each line translates to on the right, and you will see that at the end bx has the value 420 and so too does ax. So the comparison, which does ax minus bx, will set the zero flag. So question number 4 deals with SCASB. You can find information about it in lecture 4a. So SCASB is will compare AL against the destination index, which of course is given by the which has the prefix of ES register, right? The extra segment register, and it compares with that. And since we have done CLD, this has become auto increment mode, right? Which means after comparing, it will increment EDI. But there is no rep prefix, right? There is no rep over here. So ECX will not be affected. So the answer is that it doesn't increment ECX irrespective of the comparison result. And it of course compares the contents of ES:DI against AL. And similarly in question 5, it's the same thing, except that it does increment EDI irrespective of the comparison result. Right, so since DI is included in EDI, we are incrementing DI, EDI will automatically be incremented. So in question number 6, we are dealing with the CMPSB instruction. You can see that in lecture 4b, right? It compares SI and the contents of SI and DI, right, with their respective prefix segment registers, right? And then increments or decrements the source and destination indexes based on the direction flag. So this is CLD, so it's auto increment mode, right? And it will be incremented by 1 because of the byte instruction, right? But because we have the repi prefix, it will stop if they are not equal to each other. The contents are not equal to each other. So, and that is not necessarily when ECX is equal to 0. So therefore the answer is false. Question number 7, same thing with moves. You can look at lecture 4b for it. We have the rep prefix, which is all that determines when the moves B instruction stops, and so it will keep executing until ECX is the counter register is 0, right? So the Answer is true. So question number 8 is a SCASP comparison string search program, right? So we're scanning the string to find the value of 97. You can look at lecture 4a for this example, but basically we start off with di pointing to the start. So this is the start address, the address holding 42. So di starts at that, and then we compare 42 against al, because it's CASP, it compares only one byte. So it compares 42 against al, which is 97. So 42 is not equal to 97. So what happens is so after the comparison, di is auto incremented because of the clear direction flag, and now the next comparison happens. 33 is not equal to 97 and di is auto incremented, right? And then the final comparison happens where 97 is found, right? So 97, which is the index in uh, here, is equal to the al index, al value of 97, right? And of course you have one more auto increment. So the value of cx, right? But the thing is, even though di is auto incremented, uh, cx will not have this last increment, right? So cx will not have this last increment, and so the value of cx is, so over here the value of cx is 4, over here it is 3, and over here cx is 2, right? So cx will not have the auto increment, and so the value of cx will be 2. Cx will not be decremented at this point. Only di has the auto increment, right? So the value of cx is 2. And this is a question regarding the fetch, decode, execute. You can look at lecture 5 for this. The idea is, at what point in the FDE cycle is the instruction pointer incremented? So it gets incremented in decode because by the time you reach the execute stage, the EIP already points to the incremented, that is the next instruction, right? So this means that it should have only happened in the decode stage, because fetch doesn't. Fetch is about fetching it that's there in EIP, that's pointed to by EIP. So decode would be when EIP is incremented. Question number 10. When the call instruction pushes EIP to stack, run pipeline microprocessor is in which stage of FDE? Right, so execution of any instruction happens only in the execute cycle, so it is in execute. Question number 11. So we are given that the opcode size of moves B is 0, 1, right? So that means when you have EIP is replaced by EIP plus N, the value of N is equal to 0, 1. So it is IP plus 1. In this case, it's instruction pointer, not extended instruction pointer. So this is 0xFF plus 1, which is 0x1000, which is option C. So the opcode size of add is 0, 1. So it's the same thing for every instruction executed, IP gets incremented by 1. So we have 4 instructions that have been executed. So when plus 1, because the opcode size is 1, right? So for every of these instructions, you get a plus 1 increment. So the idea is that IP is now incremented by 4, and so it's 0x. It's incremented by plus 1 4 times, so it is 0x1004. The call instruction corresponds to 2 iterations of FDE, one where EIP gets pushed onto stack, and next where the microprocessor unconditionally jumps to the called subroutine. This is false because we know that every line of assembly code gets translated to one iteration of FDE. So this means that call, which is an instruction, which is an assembly line, will get translated and finished executed in one iteration of FD, not 2. So this is the thing that makes it false. Right, so you can look at lecture 5 for this. Every return instruction must have been preceded by a call, otherwise it will not execute. No, as you can see in lecture 5, all ret does is pop EIP. That is, whatever is the top of stack pointed pointing to, that data is whatever is stored in the top of stack, that data is popped into EIP. So this does not depend on anything like whether it was preceded by a call instruction or not. So this is also false. In question 15, pick all the true statements. Only B is the false statement. A, C, and D are true. Call and return both affect the stack pointer. Yes, push is what happens in call, and pop is what happens in return. So both affect the stack pointer. In B, every iteration of FDE, EIP is necessarily encrypted. No. Return is pop EIP. So EIP just takes the value that was on top of stack, which need not be need not even be an incremented version of what was there in the previous of the what was previously there in EIP. Right? Logical memory bus width and physical memory bus width can be different. Yes, this is also there in lecture. This is the first thing in lecture 1, and every line of assembly, as previously mentioned, translates to only one FD, right? So options A, C, and D are the correct options.